To continue from our previous video where we have conducted basic static analysis on the malware called Win32.Pinfi.B Malware. Now we will be conducting advanced static analysis on the malware. It's needed to give us a deeper understanding of this particular malware which we are analyzing. This will include viewing into the malicious malware assembly code, which will give us a better understanding of the malware functionality and behavior, such as knowing how the malware makes use of the imported function we have seen in basic static analysis to create the process and eventually reach its aim, which is likely to be infecting all the .exe and .scr files in the victim system. To accomplish this, we'll be using either Pro, which is the powerful deassembler tools. It is capable of deassembling an entire program and performing tasks such as function discovery, stack analysis, local variable identification, and much more. So now we'll, as shown here, and I've already preloaded it. Okay, so now what we are viewing is actually the text mode of the deassembly of the malware, and it's needed to view data regions of a binary, and it is capable of showing all the file sections that we have found previously in basic static analysis, as well as all the subroutines that are used in the main code. And now we'll look into the strings window, as shown here. Okay, so now we can actually see all the strings that we have already seen previously using bin text in static analysis. And now we'll look at the imports window. Okay, so actually we can see all the imported function used by the Win32.Pinfi.B malware, which is actually categorized based on the library that the function is from, and this information is also shown in the dependency walker, but it has actually included more information, which is the memory address that it is actually found, as shown here, this part. Okay, so now we will look into the function window. Okay, so this is the import. So we can actually get the function window from here. Okay. So actually in this function window, we are able to view all the subroutines used by the main program. And this window also associates flags with each function, such as the R flag, the F flag, the L flag. This can save you time doing analysis because you can identify and skip functions that you think are not necessary to analyze based on the flags. So now we'll look at the graph mode. Okay, so in this graph mode, we can actually see the flow of the entire malware, which includes the usage of the subroutines and how it links to each other. As you can see, there are a lot of subroutines used within the malware. So now I expand it. Yeah, so you can see all the subroutines used and how it links to each other, as well as all the imported function they are used. So now we'll close it. Okay, so now we want to look into the subroutine that actually uses back create key XA. So we can search. Okay, we can see the imported function here and the subroutine that caused it. So now we'll click on it. Okay, now for to easily view the entire subroutine, we can actually change to graph view, and we can see that it's actually caught here. Okay, so you can see that either pole have actually recognized and labeled the function local variables and parameters, and the labeled local variables corresponding to negative offset, as you can see, have up to 5 of them. And we can also see that it actually pushes the required variables and values to open the registry key, in which we have noticed that it has pushes an offset A software, which refers to software, this part. And this might show that it is actually attempting to open this particular registry software path, and we can also see that it actually uses a test function to see if the particular registry key that is trying to open actually exists. And if the test between the register EAX and EAX returns not 0, it will actually jumps to log432B9C, else it will not jump and follow the red arrow to enter the next process. And actually we can see that if it does not jump, you actually push more variable value to create a new registry key using the create key functions. Then you will test again. So as you can see, it push and it move and it calls it. Then there's a jump condition here using tests. Then we can see that if the jump is not taken, it will actually push more variables value inside and call the create key function again. And we can see that eventually all the process would end up here, where we can see that it actually conducts some checks and as well as closing the registry keys. So now we want to look at another subroutines. So we can actually jump to the function, jump to registry create to. So this is another subroutine that calls the create XA functions, in which I've actually renamed it as registry create to, and it has also set the local variables and parameters. And you can see that it actually calls the registry create subroutines, which we have actually analyzed just now. And yes, also some jump conditions using comparison between register, EDI, and ESI. Then we can see that if the jump is taken, it will actually cause the function create key. Then after calling it, it will actually close it. Alright, so based on the two subroutines that we have analyzed just now, we can assume that the malware is trying to create a new registry key within the software path in the registry. So now we will want to look at the set value. Okay, so we will look into this particular subroutines, and we can see that the set value is actually being called in this particular subroutines. Okay, so why we want to look into this particular imported functions and which subroutine is calling it? Because this is an important function which is used to set a new value for a registry key. And we can see that there's actually also global variables and values being set. Then we can also see that function WS.Pinfi.B is being called if this particular jump is being taken, which means the comparison between these two is actually 0, which means the 0 flag is set. And this particular WS.Pinfi function is actually used to write formatted data to the specific buffer, and the argument would then be converted according to the format specifications. Then afterwards, you can actually see that another important function is being called, which is the write private profile string A. And this function is used such that the variable IP file name is being pushed into this function, and it will contain the full path and file name. But if this particular file code does not exist, this function will actually create the file. So if we see here, if the jump is actually not being taken, it will actually push all the required variables and values such that then after that it will call the regset value, which means all these values that are being pushed is actually being used in this particular imported function regset value xa. Then it will close it using the rect close key. And as we can see, eventually all the process will actually end up at this particular process, and it has actually called a subroutine which being renamed as load library. And upon clicking at load library, you can see that it's actually quite a short subroutines. And we can see that there's also multiple jump conditions.